Hello, 7th graders. Guess what? We're in the last lesson. Wow. I'm so pumped. So, last lesson of our last unit on probability, and we are going to talk about comparing populations. Okay, so this is lesson 15.7. So your objectives are I can use measures of center and variation to compare populations. This is something that we learned back in unit 10. And then I can use random samples to compare populations. Skip and warm up. So essential question is, how can you compare data sets that represent two populations? Well, when we were talking about comparing sets of data, we're talking about mean or measures of center. So that's either going to be your mean and your MAD. Let's write that down. Or you're going to have your IQR and your median. Remember, we use median and median and IQR when something is skewed. And we use mean and MAD when things are symmetric. Okay, so when we're going to take a look at these sets of data, we're going to be deciding what measures of center we're using, whether we're using mean or MAD, or we're using mean and IQR. And we're going to use those data sets to compare our populations. So I think this is kind of what I just talked about, but let's see what they say as well. It says, recall that you use the mean and the mean absolute deviation, or the MAD, to describe symmetric distributions of data. You use the median and the IQR, or interquartile range, to describe skewed distributions of data. To compare two populations, use the mean and MAD when both distributions are symmetric, and use the median and the IQR when either one or both are skewed. Okay, so when they're both symmetric, we're going to keep it mean and MAD. But if one of them is skewed, or even both of them are skewed, we have to use median and IQR. Okay, again, both of them are symmetric. It's mean and MAD. If it only takes one, so one or two can be skewed, and then we're starting to go by measuring with mean or median and IQR. So this first one I kind of blacked off because we're going to go through our problem here step by step. So this first one says, example 1, the double dot plot shows the time that each candidate in a debate spent answering each of the 15 questions. Okay, so maybe it could be a political debate, it could be a debate here at school, okay? So how long in seconds it takes you to answer these questions, okay? So you've got candidate A and you've got candidate B. So we need to compare the populations using measures of center and variation. So looking at this set of data now, I think that candidate A, for the most part, is pretty symmetrical. Meaning, if I was going to probably, fold it right down here, this would match up. This is a little off, but that's okay. These would match up. This would match up. Okay? That's how you can tell it's symmetric. B is a little harder to tell it's symmetric because right now, by the looks of it, it looks like it's skewed just because of the way this number line is. But if we forget about the parts where there's no numbers here, we just look at where the dots are. If I was to draw the line right down this middle one, this part matches with this matches with this for the most part matches with this. So I would say that both of these are symmetrical, okay? When they are symmetric, we want to find our mean and we want to find our MAD. So this is what we're going to start doing. So both descriptions are approximately symmetrical. Again, it's not going to be 100% perfect. So we're going to use mean and MAD, okay? Remember, when you find your mean, you're just adding up all these dots, okay? So I would add 30 plus 30 plus 30 plus 40 plus 50 plus 50 plus 60 plus 60, so on. And I'm dividing it by 15 because there's 15 questions. So to find my mean for each one, I would sit here and add up all the points. So for candidate A, divided by 15. Candidate B, add them all up, divide by 15. That gives me my mean. Your MAD takes a lot more time to get done because then once you find your mean, you got to find your MAD. So whatever your mean is, you're going to be like, okay, I'm just going to ballpark it here, guys. I don't know what the actual answer is. But maybe your mean is 60, okay? And so then what you're going to do is you're going to have to find the distance from 30 to 60. Well, that's 30, okay? The distance from 40 to 60, that's 20. The distance from 50 to 60, that's 10. And you're going to add up all of those and again then divide by 15, okay? I already have the work out here, so, ooh, change the color. Wow, okay. So, like I said, you're adding all of them up. So, candidate A, you should get to the 1,260. Divide by 15 because there's 15 questions. You'd get a mean of 84. And for candidate B, then you have 870 divided by 15, which is a mean of 58. So then when you find your MAD, for example, A here, or candidate A, you're going to be like, okay, well, let's find the distance from 50 to 84. What's the distance from 60 to 84? And you have two 60 values, so you have to add that number twice. Once we do that, your MAD then for candidate A is 244 divided by 15, which equals 16. And your MAD for candidate B then is 236 divided by 15, which is also 16. So they rounded it. That's why they have that. I mean, it's kind of hard to see, but they have that little squiggly line. So they're rounding it, and that's why you're seeing that obviously they have different numbers on the top, but they rounded up to the nearest whole number, and for the most part, they're both 16. So the variation in the times was about the same, but candidate A has a greater mean value. So when we compare them, your MAD, so the variation in between the times is about the same, but candidate A has a greater mean, so I would be saying that candidate A tends to take longer to answer their questions. Now, I don't know if that means it's a good thing or a bad thing, because sometimes people just continue to talk and talk and talk, and they don't really get anywhere, or sometimes people are a little more direct and they can get their message across with a shorter amount of time. So then B, express the difference in the measures of center as multiples of the measure of variation. I had to go back and look at what this actually meant, okay? So it's not expanded very well. Let's see if I can move this up a little bit. Maybe not. All right. So what it means is that I'm going to take the mean minus the mean because the MAD is the same for each one. Is I want to find the difference between the two. And so I'm going to take the mean of candidate A and subtract the mean of candidate B, which is an answer of 26 because I'm taking 84 minus 58. So I get that, and I'm dividing it by the actual MAD then. So dividing by that 16. So I get an answer of 1.6, and so the difference in the means is about 1.6 times the MAD. Okay, so that's just showing you how they have the same MAD, but their means are about 1.6 times more than what the MAD is. Okay, it's a weird way to describe it. Otherwise, I mean, finding your difference between the two means works too. All right, so I want you to think about this question, and don't think too hard because the answers are a little easier than you would actually expect. So it says, what if each value in the dot plot for candidate A increased by 30 seconds? So what if candidate A decided, you know what, I wanted to expand on all my answers, and so they added an additional 30 seconds to everything. So that means that this 50, okay, would now be 80. This 80 is now going to be 110. So your whole graph is going to be shifted, basically. Okay. How does this affect the answers in example 1? What do you think is going to happen? Is the MAD going to change? Is the mean going to change? And how are they going to change? I'm not going to ask that you pause this. I just want you to kind of think in your head here, because then I'll go through and kind of explain it. Think about it. What's going to happen? So with your measures of center, the easiest one first to identify here is the MAD. The MAD is the variation between those numbers. How spread out are your length of time? And so in this case, even when we add in 30 seconds, because we're doing it to each value, your MAD stays the same. The MAD doesn't change. The data is still spread out the way that it is, and so that data, or that MAD, is still going to be about 16. As for your median, though, your median, it was about the average of how long it takes you to answer each single question. And so in this case, sorry guys, my nose is itchy again. In this case, then when your median was before was, or sorry, your mean, I keep saying median. So your mean was 84. What's going to happen to your mean is it's going to increase by that 30. Okay, that's all I'm doing. I didn't have to sit there and redo my whole graph. Every data value goes up by 30, so then my mean would also go up by 30. So that would give me an answer of 114. So your mean is going to increase. All right. Let's go on to our next example. Alrighty, so for this one, we've got some box and whisker plots. It's kind of hard for me to find a spot for my little thing to be here. So let's go ahead with the first part. It says you want to compare the cost of speeding tickets in 2 states. So the box and whisker plots show a random sample of 10 speeding tickets issued in 2 states. Compare the samples using measures of center and variation. Can you use this to make a valid comparison about speeding tickets in the 2 states? So I like box and whiskers because it's really easy to just like pull the data out and you don't have to crunch all the numbers together. So in this first one, we've got state A and state B, and we've got the cost in dollars. If I'm looking at both of my graphs, I can definitely tell with state A that it is skewed. That's because I see one really short whisker and one really long whisker. So with that being said, no matter what is state B, we are going to make this an IQR and a median measurement. So we are going to go ahead and find our IQR and our median for each one. So for my state A, I'm just going to write it up here. My median, I'm just going to go A, or M, is right here in the middle of this box. So that is 70. Okay. My IQR then is going to be this higher part minus this lower part. So my IQR then is going to be 80 minus 60, which is 20. Easy. We didn't have to sit there and calculate everything in our calculator. Okay. B, let's find our median then. My median is 80. And in this case, my IQR, we go from this end of the box to this end of the box, 100 to 70, which is 30. So can you use this to make a valid comparison about speeding tickets in the 2 states? All right, so state A has a median of about $70. And then the IQR means the range. So it could range from $20 less than that or $20 higher than that. All right. State B then, you've got a median of $86, and it could have a range of $30 less or $30 more. So I would say, if I want to compare these, I would say state B is more expensive. Yeah. Ultimately, in the long run, it's going to be more expensive. All right, I have to cut off this video, so I will catch you in part 2. Hopefully part 2 will take no more than 10 minutes at most. All right, catch you then.